guys. So today we're going to continue talking about proofs with triangles. And what I'd like to do right now is go through the last two examples from your notes packet. Now mine look a little different. I printed them out so they look a little bigger. But these are the same as the last two that are in your notes packet. So please make sure you've got your notes out in front of you, open to the very last page. These two examples here are what I'm looking at. Okay, mine are just bigger. So really what we're doing today is the same as what we were doing yesterday. Our goal is to get two triangles to be congruent, okay? And sometimes we take another step after that with CPCF, sometimes we don't. The only thing that I'm going to throw at you today is sometimes we're going to have situations where we have triangles that are sort of laying on top of one another, okay? So overlapping triangles is the new piece of today. So our ultimate goal here is to prove that BF is congruent to AC. And so to do that, I'm going to look at those two things as sides of a triangle. But you'll see one of my triangles looks like this, and one of my triangles looks like this. So they've got this side BA sort of in common, okay? Which again, will probably mean that we're going to be using reflexive property here because we're going to want this side in the yellow triangle to be congruent to that same side in the pink triangle. Okay, so let's start out here. Regular hexagon ABCDEF, that's what's given to us. So again, our first step is always to list the given. Now this, I can't remember if we talked about this word or not, but in polygons, when I say something is regular, you may want to jot this down in case it pops up in homework or something. Regular means all sides and angles are congruent to each other. So, for example, an equilateral triangle, we would call that a regular triangle because all the sides are equal, all the angles are equal. Okay? So, knowing that it's regular, that tells us that all 6 of these sides around the outside are congruent to each other. We don't need all 6 though. Let's think about what we do actually need. If I'm trying to get the yellow triangle to be congruent to the pink triangle, I'm going to need this side and this side to be congruent to one another, and that's AF and BC. And again, I knew that because that's what it means to be regular, okay? So straight from my given, that's definition of regular. And then really similarly, because, okay, I'm going to jump ahead a little bit here, but I already mentioned that eventually we're going to have AB be congruent to AB, right? And that's going to be by the reflexive property. So it looks like in this one, they've already got that filled in as step 3. If you were doing this on your own and you made that be your next step, that would be totally fine. Okay, the order of these steps doesn't matter so much. So looking at this, I have 2 sides here congruent to 2 sides here, okay? And I need to think about what else could I get to be congruent that would make these triangles congruent. Well, I know side, side, side is not going to work because I don't have a way to get these 2 sides to be congruent. And I know that because ultimately that's what I'm trying to prove. So they're not already congruent. At least I don't know that they're already congruent. So side, side, side doesn't work. My other option using 2 sides would be side, angle, side. That means I would need this angle here at B to be congruent to this angle here at A. Can you see that in the 2 triangles? That this is sandwiched between these 2. Angle A is sandwiched between those 2. And then angle B is sandwiched between these 2. So, and because there's more than one angle at A, I do have to be specific. So this angle I would name FAB, and this angle I would name CBA or ABC. And again, the reason I know that is because of this, because I know that it's regular, so I know all those angles on the inside are going to be congruent to each other. So that's a really helpful word to know because that gets you a lot of stuff to be congruent. So now I know that my triangles are congruent. I know triangle FAB I'm so sorry. Has to be congruent to, and if I name this one FAB, I have to look at what side goes with FA. FA corresponds with CB, so I would name my other one CBA. And again, we had already sort of talked about this, but that's the side angle side theorem. And then remember, now that I know that my two triangles are congruent, I can say all of their other pieces are congruent. So I could say, like, angle F has to be congruent to angle C. Or I could say, let's see, I guess everything else is already sort of congruent, but I could say this little angle is congruent to this little angle. But the only one of those things I really care about is what I was trying to prove in the first place. I was trying to prove that BF has to be congruent to AC. And if you look at how we named our triangles, do you see that BF and AC are in corresponding positions? So now I know that those pieces are congruent by CPCF. Okay, that's how CPCF works. Okay, let's look down at this one. So this is your next example. Look at all this information I'm given. I'm given that PA is congruent to PB, so I'm going to mark that right away. PA is congruent to PB. And that CA, so this whole thing, I guess I'll mark it there, is congruent to this whole thing, to DB. Okay, that's kind of a tough one because it's hard to tell, what's what. Let's go ahead and write this in. PA is congruent to PB, and CA is congruent to DB. Okay, and what I'm ultimately trying to prove is that DA over here is congruent to CB over here. Okay, and I actually see a couple of different ways I could go about this, but ultimately what I want is I want these two to be pieces of two triangles that are congruent to one another. Okay, and I think the way I'm going to go about that is, let's see here. I want to look at triangle DBA and triangle CBA, like this. And sometimes it's helpful to draw those triangles separately. So like, for example, I have some space here. Here's triangle DAB. DAB. And then here's triangle, I did not make those look congruent, but this would be triangle CAB here. So I kind of took those two triangles apart. Okay? Oh, down here, sorry, this was given. Now, taking them apart, though, might make you miss that. Do you see that they share this side in common? AB is congruent to itself. So in my separate pictures, that means this and this have to be equal. Okay? And if I translate my given information, I know that these two longer sides have to be equal as well. So I've got this congruent to this. Okay? So that piece was given what we just said, this being congruent to that. That's this being congruent to itself, so that's the reflexive property. Now, you may be thinking, and actually, I shouldn't use one mark here, I'm going to use 3, because I used one mark down here. What good did these two sides do me? Because when I drew my bigger triangles separately, those two pieces weren't in there. Like, this is like a piece of this side, and this is like a piece of, well, sorry, I said that backwards. This is like a piece of this side. This is like a piece of this side, but they don't actually show up in the triangle. So why is that helpful? Well, they wouldn't give it to you if you didn't need to use it for something. But what I am seeing is, if I look at this down here as its own triangle, what I have there is an isosceles triangle because of these two sides being congruent. Okay? And so if I have an isosceles triangle down there, and these two are congruent, think about what we know about isosceles triangles. We know that this has to be congruent to this, the angles I mean. So this angle here has to be congruent to this angle here. Let's look at how we would name that. this angle would be named PAB or CAB, it doesn't matter. And that's going to be congruent to this angle, which is PBA. And maybe it actually would make more sense if instead of using P, I use C and D. So this angle was CAB. And this angle was DBA. And the reason that I said it'd probably be better to do that is because this letter P doesn't show up in my pictures up here at all. Okay, so, but CAB does. So now I know this angle is congruent to DBA, which is this one. So sorry about that. I should have gone with P from the beginning. Okay. So now, looking at my pictures, do you see side angle side in there? So now my triangles are congruent. Triangle DBA must be congruent to triangle. I'm going to name this one the same way, so that'd be CAB. And that's by side angle side. That's what we said here. And then our last step is to say, well, now I know this and this have to be equal because I know the whole triangles are equal. So now I know that DA is congruent to CB. And again, that's by CPCF. So CPCF is always going to immediately follow one of your triangle congruence theorems, and only if what you're trying to prove is like a piece of the triangles, not the whole thing. Okay? Okay, let's talk homework for tonight. And I know I wrote it on the board, but I want to make sure you're clear on what I expect of you. From your packet, so this is now your homework packet. Last night you did 7-3 modified, so you did this one, and you should have done front and back, and hopefully you've checked those already. Right now, in class, I expect you to do Lesson Master 7-4 modified. So these ones just want you to draw the overlapping triangles separately, kind of like we did here, okay? And then there's 3 proofs for you to try. There's one here, and then there's 2 on the back. Those need to be done before you leave today. Mrs. Peters will be checking them for you to say that they're complete. Homework for this weekend, which you can also start after you finish that other assignment. The whole rest of your packet is proofs, okay? No, I'm not going to ask you to do the whole thing this weekend. There's 10 of them in here. What I would like you to do is choose 3 out of the remaining 10. So if you look, and the pages are even numbered down here at the bottom, okay? There are 10 proofs in the rest of this packet. I want you to pick 3 of them. Now we're getting away from the fill in the blank and you're just writing it totally on your own, okay? But I want you to try 3 of them, only this part of it, not the paragraph. You do not have to do the paragraph on any of them, okay? So it's just this top part, just the proof on the top. By the way, we made these tables very generic, okay? Just because there's this many lines doesn't mean you'll need that many lines in your proof, okay? So homework for the weekend, after you finish 7-4B, that should be done in class. And then you can start working on 3 of the proofs that are anywhere in these last 10 pages. Okay, you pick which one you feel like doing. Knock it out, give it a shot, and then we will go over these when you come back to class on Monday. Okay? Have a great weekend.